On the bench today, we've got a pair of Topward dual tracking DC power supplies. These feature two independent or tracking 30 volt 3 amp analog supplies plus a fixed 5 volt 3 amp supply. So ideal for logic and analog circuits, especially if they have op amps in them. Very nice classic lab power supplies. Right, we've got the power supply opened up, and the first thing I noticed is that the transformer is bulging, and that will almost certainly be because there is rust in between the transformer plates. So this has been exposed to some moisture for some time. It's harmless, but it just indicates that it hasn't been stored under ideal conditions. But the rest of it is in pretty good nick. There's quite a bit of dust in here, and for a piece of equipment with no fan, that would tend to indicate that the operating conditions were quite dusty. But that shouldn't affect operation or resurrection of this power supply. It's still in good condition inside. Okay, I'm going to apply power to this. Now, to start off with, the power is basically 0 volts, so I don't expect anything at all to happen. So I'll switch on the main supply. I've got the Variac set up to 0 volts, and I've got the power switch set to off. So we've got power on the power supply, nothing's happening, which is what I'd expect. And let's just wind up the volts to 20%. I'm going to leave that for a while to give the power supply time to reform the capacitors, and I'll come back. Right, I'm just going to wind up the voltage. It's 20%, which is about 40 volts. I'm going to wind it up to 40%, which should be about 80 volts. The Variac has 100% power applied, and if we look at the power meter, that's showing that there's 20 watts. So about 4 of that is from the Variac. So this power supply is using roughly 15 watts with no load. And if we look at the front panel, we can see that I've got 25 volts set up with no load, nothing connected. And if I turn the current right down to 0, then the voltage goes to 0, which is exactly what you expect. You might be able to hear there's a relay clicking in the background. And the other one works as well. If I turn the current to 0, you can hear a relay click and the voltage goes to 0. And I've measured the output on the 5 volt supply, and that's all working fine as well. So right now what I'm going to do is I'm just going to leave this running with no load as a soak test, just to make sure that there's no latent defects in there. If there's any component that is thinking about it wants to give up life, and hopefully it should do it over the next couple of 3 hours. But this power supply is indicating that it's fully operational. The capacitors have been fully reformed. There's no magic smoke disappearing, and it's all looking good. Job done. Okay, now ready to start rejuvenating the second power supply, and opening it up, it looks exactly the same as the other one. Quite dusty inside, but physically there's nothing burnt. There's no funny smells, and interestingly, the transformer has got that bulged look from light rust in between the plates resulting from moisture. The front panel on this looks really good. It just looks like brand new. So basically it looks in good condition. It just needs the capacitors reformed to make sure that they are fully functional and fully restored to operation. So one of the key advantages of these old power supplies is no fan. They just have these huge heat sinks on the back to get rid of all the surplus heat. These classic power supplies are really easy to use. quite heavy. This one weighs at 9.6 kilograms. That's what you get with linear supplies. No fan, lots of weight, very quiet, low noise output, because that's one of the key advantages of an analog output. And this particular power supply is in very nice condition. You can see that the front panel doesn't have any dents or scratches or anything else on it. So this is, yeah, good stuff.